Creating efficient thermal models of entire subsystems is easily done using the export feature. To demonstrate this, I will construct a model of a transmit-receive module containing several MMICs that were already created. The first element of the TR module will be a two-stage power amplifier similar to the one discussed in the MMIC thermal analysis tutorial. I will export this MMIC onto a two-layer module. I do this by selecting a device template file that has a representation of the layers for the module. These layers get appended to a simplified device representation. So if I open the exported power amp, what I find is it's a simplified version of the MMIC that provides for a more efficient thermal analysis of the module. The details of the FET metal layers have been removed, but an equivalent amount of power is delivered to the surface of the substrate. I can see this by loading in a solution for this device. Now what I want to do is set a couple of the offsets down from their default value of 200 microns to 50 microns so that I can put two of these power amps close together in the final module layout. Next, I'm going to open this driver amp MMIC, and this layout contains a couple of FETs that were also derived, as all the FETs were, from the generic FET template. So I'll just export this onto the module as well. And open the exported device and change one of the offsets to 50 microns. Next, I'm going to export this power amp, this post amp onto the module. And finally, I'm going to create a rectangular heat source that I can use to represent other sources of heat on the TR module, like a phase shifter, attenuator, or limiter, or something else like that. So I'm going to start from the mesa resistor S, which is a surface flux defined in a rectangular area, and I'm going to configure the geometry to match what I want for my module component. I'm going to set the power dissipation in this device to 4.5 watts. Now I'll save this device to a new file. And then I'm going to create a layout for the device. And the reason I create a layout is because I want the device to be exported onto the module, and that can only be done from a layout. So once I've created a layout and saved it, I can export it onto the module. Now if I open that exported device and adjust the geometry, I now have all the devices that I need for my TR module. So what I'm going to do is create a layout for the TR module. And the first element of that layout will be this PSAL export device. So let me set the overall length and width of our module. And increase the mesh size to some more reasonable value for such a large layout. Then we'll position the PSAL device in X and Y and add the rest of our devices. So the driver amp, a couple of power amps, the post amp, and another PSAL device. and then just set the positions on these as well. And this last one will turn it clockwise 90 degrees. So that's our TR module, and we can save that layout. And now we have a complete model that we can use for thermal analysis. All we would have to do is say run simulation, which I've already done, and I'll just load in the solution here. So there's the thermal analysis of our TR module. Now if we wanted to, we could include this TR module in a more complex subsystem, such as a line replaceable unit, or LRU. So to do that, basically we would start by exporting the TR module onto the LRU layers. So if we look at the exported device, what we see is the TR module and the additional LRU layers underneath. And then we can create a layout for our LRU and specify the dimensions. Choose an appropriate mesh size. And then we can create several copies of the TR module in different locations on the device. Now if we had some other heat sources on this LRU, such as some power converters, we could include those by creating devices for them. So let's just save this layout first. And then we would could open up these other heat sources that we had and export them onto the LRU. So I have a square heat source that I want to use, and a rectangular heat source. And these I've already defined, so I just export them. Now if we go back to our LRU layout, we can just edit the layout and add these devices to it. So let's add a couple of these square heat sources and 3 of the rectangular heat sources. And type in the X and Y locations. And we're all done. So there's a complete model of our LRU, and again we can save this and run a simulation, which I've already done, and I'll just show you the results of our LRU thermal analysis.